Assalamu alaikum everyone, and today we are going to see the Pythagorean Theorem. Woo! Okay, so the Pythagorean Theorem, also known as the Pythagoras' Theorem, is a geometric relationship of right triangles. So, the Pythagorean Theorem, first of all, you would think, what is a theorem? And who in the world is Pythagoras? Well, there is a Greek man who invented this theorem, whose name is Pythagoras. Historians aren't really sure if he made it. I mean, it could be his students or followers, but he mostly gets the credit for it, you know? So, now we have Pythagoras covered. Let's see a theorem. A theorem is a statement. Means it's true. Like 2 plus 2 equals 4. Okay, 2 plus 2 equals 4 isn't exactly a theorem, but it's something like a hypothesis that is proven to be a truth. Also, it's also called a theory, but mostly we call it a theorem. So now we've got all that covered. Let's see how the Pythagorean theorem goes. Okay, sure, this is about geometry, but we will need some basic background knowledge of algebra. So in the link in the description below, I'm going to list all the algebra videos I have that will be, inshallah, helpful for you to understand this theorem if you forgot those things or you didn't see them. But if you did, you also need some background knowledge of exponents and square roots, and also angles and triangles. I'll leave all the links in the description below so you can watch it. If you have all those covered, let's see the Pythagorean theorem. So there are many ways the theorem goes, but this is how it goes. This is the one we will talk about today. For a right triangle with legs A, B, and hypotenuse C, A squared plus B squared equals to C squared. So this is the Pythagorean theorem. Okay, don't just leave the video as, oh, this is that, so let me enjoy the day. No, you need some explanation first. So what it says is, if we take a right triangle, wait, this is not. So it says if we take a right triangle, like the one I have here, with the legs, these are called the legs, which make up the angle. With legs A, B, this is the longest part of the triangle, the hypotenuse. C, the hypotenuse is the one that is not making the triangle. So what it's saying is if we take the square of A and the square of B, we get the square of the hypotenuse. Now let's see this in action. let's say we have 3 by 4 here. This is 4, this is 3, and we are trying to figure out the hypotenuse, which is 5. If we take and square the 3, this isn't a perfect square, but don't worry now, just listen. And if we take the square of the 4, we would get the square of this part, which is 25. I just wrote here, like there would be 25 squares. But is it true though? Let's see, 16 plus 9, which are the amount of squares, is equal to 25. Wow, those Greek people were smart. Now let's see this theorem in action. Woo! So, I have this book here again. You can see it. So what it is helpful for is to find out what we don't know from using something that we do know. Okay, so let's see this triangle with 4 meter sides and 7 meter sides. What would be the third triangle? Now, time for some algebra, exponents and square roots, background. To find this out, we need 7 squared plus 4 squared equals to c squared. We square the 7, 35 plus 4, you know, those boring stuff. Now add them up. So simply do some rough work if you need to. And 51 is the square root of the if we take the hypotenuse and square it. To know the hypotenuse, we need to take the square root from both sides, because we learned that in algebra. See the application? So we take the square root from both sides. Now this square would cross, leaving c all by itself, but the hypotenuse 51, you know, isn't a perfect square. So we would just write the square root of 51. But if you need to, you can simply use your scientific calculator, as is here, and then plug the number. Beep, boop, beep, boop. And I get 7.141428429, etc. And it keeps going on forever with no ending, no repeat. So we can see another basic application. Remember, we said that we have to use it on a right triangle. I wouldn't show the angle sign here, which would make it harder. So let's choose it to find a test if this is actually a right triangle. So the sides 3, we know these are the legs and this is the hypotenuse, because the hypotenuse is the longest side. So 3 squared 9 plus 9. Uh-oh! We got something really confusing here. This is not a true statement. Therefore, this is not a right triangle. Let me show you one cool fact before we go, because we're almost done. If we have a unit square, 1, 1, the diagonal would be 1 squared plus 1 squared equals to c squared. 1 plus 1 equals to 2. C squared, the square root of 2 equals to c. And so the diagonal from one corner to the square and the other corner to the square root of 2. And that's all there is to it. Thank you for watching, and I'll see you next time. Bye!